Okay, welcome to the last lesson in our Unit 4. I know how much you're going to miss functions after we finish this lesson, but this really pulls everything together that we've been talking about. How to understand function notation, what it means to graph a function, what is your input and output, what is your domain. Now we're introducing you to inverse functions to solve problems. So all of this comes together now in our understanding of what it means to be a function and how we can use functions to solve problems, whether it is problems in our understanding here, but also problems in our real world and what is actually important for your input and for your output for the situation that you are in. So your learning objective today is you can write a linear function to model the given data and find that inverse of the function. And so we'll go a little bit more into what that actually means. Right, a tank contains some water. The function W represents the relationship between time in minutes and the amount of water in tank in liters. The equation W of t equals 80 minus 2.5 t defines this function. So the first thing you want to do is sketch your graph. If you need to go back to how to sketch linear equations, go back to lessons 10 and 11 in your Unit 2. Those practice problems will definitely help you going over how to sketch a graph of a linear function. Then you want to talk about what is the story, right? Going back to lesson 1, how is this water in the tank changing? Be specific as possible. What is the initial amount in the tank? How is it decreasing each time? How is it increasing each time, right? Think what is actually happening here. So first sketch your graph. The first thing you want to do when sketching your graph is to find your input and output values, right? In this case, we have a relationship between time in minutes and the amount of water in the tank. So what is your input value? What is your output value? Once you label your axes, right, you can just quickly label your axes, right? This is my input value, and this up here is my y-axis is my output value, whatever that is in there. Use that to help you sketch your graph, right? Where does my initial value start? How should I be drawing my line? And then describe what it means in your context. How is a water tank changing? Make sure you're being very specific. This goes back to lesson 1. And then what does W of t represent, right? We know W of t is our output value. And so what does W of t represent as a whole? That goes back to lessons 2 and 3, right? We're starting back from the beginning. What does it mean in function notation? And so pushing it a little bit further, how do we use function notation to solve our problems, lessons 4 and 5, right? How much water is the tank after 3 minutes? How many minutes will it take until the tank has 5 liters of water? Pay very close attention on how you solve this problem. Make sure you write out each of your steps because that will help you in understanding from finding the inverse function of W. And the very last step, find that inverse and show your reasoning, right? Remember when you're finding your inverse, and if this is something you're struggling with, go to the previous lesson video, right? When finding our inverse, our goal is to isolate our initial output, right? How do I isolate this value? What operations do I see here, right? What do I do to get t? My goal is to get some sort of t equals some value. And so that's definitely what you want to do in finding your inverse of your function. And so you can keep this as WT as well, right? I'll give you the first step, right? If I want to isolate t by itself, I need to get rid of this 80 first. And so I'm going to subtract by 80 on both sides of my equation. This is going to give me W of t minus 80 is equal to negative 2.5 t, right? And then what is my last step here, right? How do I get t by itself? What operation do I see here? And so that will help you find your inverse of your function. And going a little further, like we talked about in lesson 6, but also in our previous lesson before, here are the two graphs of our functions. We have our time in minutes as a function of the amount of water and our amount of water in tank as a function of time, right? Looking at both of these relationships, what do you notice here? Remember, you can also manipulate the graph as well. You can see your intercepts, what is happening what do you notice here between our intercepts of our function? What does our input mean? What does our output mean? Input is your x value, output is your y value, right? Going back into that, right? Write two things that you notice from the graphs. Think a little bit deeper than what we were talking about before. And last but not least, understanding function notation in context with phones and homes. 2014, less than 5% of the homes relied on only a cell phone. Since then, the percentage of homes that use only cell phones has increased. Obviously, things are more cheaper and more accessible. It's defined by this function. First thing you want to do is label your axes. To do that, you want to go up to this graph settings button up here. You click on that, and to add a label, I'll move this down for a second. To add a label, you want to add your label. I know that it is a function of years since 2004. So for my first things first, I want to label my graph. My x-axis is time. In this case, it's years since 2004. You can see it coming up at the bottom here. And so you want to do the same for your y-axis. What is your output value of this function? And don't forget, what does the value p of 6 represent? What does that input of 6 represent? Remember, you're looking in context, and you can always manipulate the graph to see what is happening when my input is 6. What is my output value, right? And if you need to drag up the graph a little bit more, or you need to zoom in or anything, feel free to do that. But don't forget to answer this question as well. And last but not least, wrapping up this unit, right, understanding what does the equation here represent. This is actually before the mid-unit. You had a question similar to this on the mid-unit, so go back there if you need to see what that looks like. And we want to know the percentage of homes with only a cell phone. Understanding reaches 50%, 75%, or 100%. What equation would help us? Think about what the title of our lesson is for today, and how that could help you understand what it means in our context. And so last but not least, if you want another example, head out to the lesson summary, or make sure you ask me questions in class today. So that wraps up Unit 4, and I will see you with Unit 5 next week.